Okay, this is a continuation of section 1.4b. Appears it cut off right at the point where I was doing problem 1, I believe. So I'm just going to start from number 1 again. In this worksheet, you are learning to simplify complex numbers. And if you remember, I is a radical defined as square root of -1. So when you have a radical combined with a number, that's a complex number. And we're going to try and get rid of the radical that is in the bottom in the denominator. Now, since this is connected to another number, the only way you can get rid of it is to multiply by what's called the conjugate, which is what I'm writing here. It is this expression with the sign in front of the imaginary portion, because all complex numbers have an imaginary portion and a real portion. So you have to switch the sign in front of the imaginary portion. Don't forget to multiply the top by that same expression, which is called, as I said, the conjugate. Okay, now whenever you multiply conjugates, now this is whether you're doing complex numbers or whether you're using x plus y and x minus y. Those would be considered conjugates as well. There is a shortcut for foiling conjugates, and that shortcut is square minus square. So you can save yourself a few steps by using that shortcut instead of using the arrows that go first times first, outer times outer, inner times inner, last times last, and then still having to combine like terms and still having to deal with the I squared. So this will cut out a few steps for you. When you're doing square minus square as the shortcut for foiling conjugates, you can just either be looking at the first binomial or the second one, really doesn't matter, and then perform this shortcut. So I'll just do it right here. Square the front term and it's 81, square the back term and it's I squared, okay? 81, I squared, and it's a minus in between those two squares. If you want to continue working on the bottom, just so you're not jumping back and forth between the top and the bottom, you can get in here. Don't forget, I squared is defined as the real number, -1. This is an imaginary number. This is a real number. So you can get in here and actually simplify. You can go 81 minus what I squared is equal to, which is -1. This becomes 81 plus 1 because of the double negative. And so you end up with 82 on the bottom. Okay, then going up to the numerator, all you're doing is simple distribution using the 6. So this would be 6 times 9, 54, and then 6 times I, 6I. And then you want to reduce, if possible, once you get to this stage of the answer. Reducing something like this, that's a complex number on the top and a real number, you want to make sure that anything you're considering for reducing this fraction goes into this, this, and this. And you can see that all of these numbers are even. So 2 goes into 54 this many times. 2 divides into 6 3 times. And 2 goes into 82 41 times. And maybe you want to put that here in your notes, that's how I got the answer. Okay, likewise, same thing here. You're multiplying by 3 minus I. This approach of using a conjugate is taken whenever the imaginary number is connected to the real number by way of a plus or minus sign. And you're trying to get rid of that complex number in the denominator. So on the bottom, again, using the shortcut square minus square, I'm going to square the front term, square that back term. You don't need to do that to both of these. Do it to one or the other. You're going to get the same answer either way. So front term squared is 9, back term squared is I squared, and then put the minus in there. Continue working on the bottom until you have a single number. This would be 9 minus I squared is defined as negative 1. Therefore, I can replace I squared with negative 1, which means that this is really 9 plus 1. So the bottom ultimately becomes a 10. Then going back up to the numerator where I am multiplying 20i, distributing it to each of the terms inside the parentheses. So 20i times 3, that would be 60i. And then 20i times negative I would be negative 20i squared. Once again, the I squared term appears in your answer, and so you need to replace it. So this will be 60 minus 20. I squared is defined as negative 1. So this will be 60 plus 20 on the top, because negative times negative ends up being positive. Therefore, you have 80 over 10, or just 8. Okay, it's the same problems over and over again. I'm going to skip to number 4. There's not many. There's one concept here: how to get rid of these denominators by way of a conjugate. Conjugate right here is 2 minus 3i. This is 2 minus 3i. Okay, so in this problem, you jump up a level because not only are you going to FOIL on the bottom, but you're also going to FOIL on the top. And that's because you have a binomial here and a binomial here. That calls for FOILing. Binomials are bigger when you're multiplying, call for FOILing. It's just that on the bottom, you have a shortcut available, whereas on the top, you do not. You will have to do full-blown FOILing. Okay, so when we start working this out, I'm going to use my shortcut on the bottom, work on the bottom first until I get it completely simplified. So I'm going to square the front term, square the back term. So it's 4, and then the back term would be 9i squared when I square both portions. And you put the minus in there, continue to simplify the denominator. So this is 4 minus 9. The I squared gets replaced by negative 1. And you end up with 4 plus 9. So the bottom ends up being 13. On the top, there's no shortcut. Therefore, you have to know how to do regular FOILing. First times first, outer times outer. In other words, the first term multiplied by each of the terms in the second parenthesis. Then inner times inner. This is where the word FOIL comes from. Last times last. Just follow each of the arrows, the short one, then the long one. First do the upward ones, then the upside down ones. Each time you follow those arrows, you'll be multiplying. So 4 times 2, 8. Long one, 4 times negative 3i would be negative 12i. Okay, then the short upside down arrows, 7i times 2. They're both positive, so that's going to be positive 14i squared. And then that upside down long arrow is going to be 7 times negative 3 is negative 21i squared. Okay. Then if I come right in here and I try to put these together, and I think I have a square here that doesn't belong. When I was doing this 7i times 2, that should have just been 14i. So let me fix that. Should have been just 14i. That was for that small upside down arrow, and then negative 21i squared. Okay. So then when I start combining things, I have down here at the end a negative 21, and the I squared gets replaced by negative 1, which really means I have a positive 21. That positive 21, that positive 21 gets combined with 8. Sorry, my dogs are going nutty. And then when you go negative 12i plus 14i, you get positive 2i. Okay, and then you can just bring that right down here. Okay, so just real quick review right here. 4 times 2 is 8. 4 times negative 3 was negative 12i. 7i times 2 was 14i. 7i times negative 3i was negative 21i squared. The I squared got replaced by negative 1, turned into a real number, and combined with the 8, which is where we got the 29, and then the two middle terms were combined. Okay, and that's the answer. You cannot reduce that because there's no number that goes into all three of those. Okay, number 5, last problem, happens to be a multiple choice. I don't know if all the choices, usually there's 4 choices here, and when you put this in print form, a couple of the answers will typically get cut off if it's multiple choice. So it doesn't stop you from doing the problem, though. You can still work the problem. You have an answer key because all of these outlines I saved for you in the content folder with an answer key. So it's not going to stop you from doing the problem, even if a couple of answers do get cut off. When you get into my math lab, you'll see all 4 of them. Just make sure that you can work the problem. Okay, so they want to know if this is equal to 7 sixes. So we're going to remove the problem the complex fraction that we're working on here. We're going to try and rationalize it, which has been the theme of this whole worksheet here, by multiplying by 6 minus 2i and 6 minus 2i on the top and the bottom. Okay, on the bottom I'll use the shortcut. Square the front term, square the back term. Put the minus in there. Continue working on the bottom, and it's minus 4 times I squared, which ends up being 36. Negative 4 times negative 1 is positive 4. So 36 plus 4 is 40. Okay, just check that real quick. Minus 4 I squared. That was negative 4 times that's okay. So everything's good there. Then here you're going to have to just FOIL. So 7 times 6 is 42. And then 7 times negative 2i is negative 14i. And then 2i times 6 is 12i. And then 2i times negative 2i is negative 4i squared. So this would be 42. I'll do this negative 4 times I squared right here so you can see that it's really a positive 4. It's negative 4 times negative 1, which is positive 4. So that combined with that is, let's see, I'm working on the top, 46. And then these 2 terms in the middle, I mean, without finishing it, you could tell you're going to have an I term, and you could tell that even when you were foiling here. So those combined is just negative 2i. Anyway, there's no need to even reduce it because the question was that when you simplify this, do you get 7 sixes? And you don't. So that statement is false. I don't know if that answer is showing here, but we can look at the choices that there are here. Given statement, the correct statement is, the given statement is true. That's not the answer, part B. The given statement, the correct statement is that this simplifies to, so I guess you did need to do all of this anyway, so we will have to simplify. So we had gotten all the way to 46 minus 2i over 40, and ultimately when you reduce that, 2 goes into the top 23 times, 2 goes into 2i 1 time, and 2 divides into the bottom 20 times. Okay, that completes section 1.4b.